Hello everyone. Today we're going to be talking about electric field in electrostatics. In our last class, we talked about electric force and Coulomb's law, which states that our F equals to KQ1 Q2 over R squared. And among this expression, our F is equals to or is inversely proportional to 1 over R squared. This expression is known as the inverse law. However, going to the main topic for today. Electric field is a region of space where a charge is likely to be found. It is a region of space where a charge is likely to be found, and the formula is E equals force, the force exerted on that unit particle found in a space per unit charge Q equals to the force per unit charge Q. But recall from here that our F equals KQ1 Q2 over R squared. Then bringing this back into the equation we have down here, it was going to be our E equals KQ1 Q2 over R squared all over our Q that we have from here. Assuming that our Q1 is equal to our Q2 and that's equals to our Q. That means our F is going to become KQ times Q all over R squared, giving us KQ squared over R squared. Now then, going back to our initial equation, which is E equals force over Q, our force becomes KQ squared over R squared and over the Q of the electric field. Now one charge cancels one charge here, and our final answer is going to be KQ over R squared. KQ over R squared. So currently we have three expressions under electrostatics. The initial one was given to be our F equals KQ squared over R squared, known as the Coulomb's law. And the second one was given to us as the force equals QE, that is the force acting on a charged particle inside an electric field. And the last one was given to be E equals KQ over R squared, where E is our electric field, or R is the distance between the charge and a particular point in an electric field, and the charge itself is the one found in that electric field and the one a force is being exerted on. Now then, let's try these formulas in a question so get ourselves familiarized with it. So what's our question here? We're given a line, an electric field in particular, with a charge of 4 microcoulombs present, a positive charge of 4 microcoulombs present, and we are asked to find the electric field at point X. We are asked to find the electric field at point X. Therefore, completing the question, the distance between this charge and point X is precisely 0.4 meter. So when we are asked to find the electric field at point X, the first thing that comes to our head is our initial formula given, which is our E equals KQ all over R squared. Recall that our our K has been given to be 9 times 10 raised to power 9, and our Q is 4 times 10 raised to power minus 6, and our R squared, our R is 0.4 meter squared. Now, given our final answer, E equals 225,000. What will be our unit? Recall that our electric field equals force per hour charge. So our unit here is going to be Newton per coulomb because it is force per charge. So you can see our new question is giving us a triangular form of electric field, and we're given two like charges plus 4 microcoulombs and 6 plus 6 microcoulombs, and we're asked to find the electric field exerted by individual charges at point P with a given distance in between them. At point P with a given distance in between them. Now, first let us make our annotations by using a graph, a mapped graph. We have for our 4UC here, in which the direction from 4UC towards P is diagonal. The direction from it is diagonal, and as you can see, it is acting in the positive Y direction and also in the positive X direction. This is going to help us when we are done solving our questions. Likewise, for our 6UC, our 6UC is also moving diagonally to our point P, and it is moving in the negative X direction, whereas it is moving in the positive Y direction. So then let's find our E1, which is for our positive 4 microcoulombs, and our E2, which is for our positive 6 microcoulombs. How do we do that? We do the same thing we've done before using our E equals KQ over R squared. So our E1 equals KQ over R squared equals 9 times 10 raised to the power 9 times 4 times 10 raised to the power minus 6 all over R squared, which is the distance between our 4 and P here is 0.5, and that's squared. So our E1 using our calculator is going to be giving us 144,000, and the unit is in Newton per coulombs. So that gives us the first answer for our E1. But then let's solve for our E2. Our E2, we also follow the same process, KQ over R squared equals 9 times 10 raised to the power 9. Our Q is 6 times 10 raised to the power minus 6. That is for the direction here. And over R, our R between 6 and P is also 0.5 meter squared. So our E2 using our calculator is going to give us plus 216,000, and our unit is Newton per coulombs. So that gives us the value for our E1 and E2, but we are not done there because we have to resolve this component into both the vertical and the horizontal component. How do we do that? So we can do this by drawing a diagram for each charge. Our charge 1, which is 4UC, and our charge 2, which is our 6 microcoulombs. So how do we draw the diagram? Mapping it. By mapping it, our Q1 is acting towards P in this direction and in the direction of positive X and positive Y. This is the direction in which it is acting. But then what about our Q2? Our Q2 is acting to the left in a likewise manner as our Q1. The difference between them this time around is that although our Q2 is also acting in the positive Y direction, it is acting to the left, which is the negative X direction. So by resolving our components, we need to find an angle. For our E1, the horizontal component of our E1 is going to be E1X. It's going to be E1X, and our E1X is going to be E1 cos theta. Whereas for our E1Y, our E1Y is going to be E1 sine theta for the vertical axis. So we need to first find our theta here before we can solve anything. How do we get our theta? Looking at this diagram very well, you will notice that it is an isosceles triangle, which means two sides are equal. Now, having that, it means we can split our triangle into two, and by doing that, we're going to be having a right-angled triangle with our 0.2 here, since here is 0.4, splitting into 2 will give us 0.2, and our 0.5 is still there, our 0.5 meter, and our theta here. Now, how do we find our theta? By using cos. Cos theta equals 0.2, that is adjacent, over hypotenuse 0.5. So the theta inverse, the cos theta inverse, is going to be giving us our answer to be 66.42. 66.42 according to our calculator degree. So then we can go on to resolve our components to both the x and y axis. recall that we said for our horizontal component for our first part, which is E1, is going to be E1 cos theta. And we've already gotten our theta, so therefore our E1 is going to be what? It's going to be 144,000 times cos 66.41. And the answer for our E1x is going to be, using our calculator, 57,600 Newton per coulomb. So this is positive 57,600 Newton per coulomb because it is acting in the positive direction of x. Then what about our y? Our E1y, that is the vertical component, is going to be E1 sine theta. It's going to be E1 sine theta, and that is equals to 144,000 sine 66.41. So using our calculator, our E1y is going to give us 131,976.4 Newton per coulomb. So this gives us our resultant for E1x and EY1x. Now the next thing we have to find is for our E2. How do we do that? By using the same method we've used there. So our E2x equals to our E2 cos theta, and that is 21600 times cos 66.41, and our E2x is going to be giving us a value of 86,400 according to our calculator, Newton per coulombs. Likewise for our E2y equals E2 sine theta, and that is equals to our 21600 times cos 66.41. So our answer for that is going to be E2y equals 197,965 Newton per coulomb. So having gotten our values for E1x, E1y, E2x, and E2y, we have to resolve all the components of x into 1x and all the components of y into 1y. So for our x component, remember that our E1 is in the direction of the electric field, which is positive, whereas our E2 is in the opposite direction to our electric field, which is negative. And according to the law of vectors, their resultant is gotten by separating them. That means our x component will be equals to E1x minus E2x. So how do we do that? How do we continue? Our x here is, what's our E1x from the initial solving we've done? Our E1x is 57,600, and our E2x is 86,400. Okay, so what's going to be our final answer there? So for our x component, the answer is 28,800 Newton per coulombs. Okay, let's do the same thing for our y. For our y component, remember that both E1 and E2 are moving in the same direction. That means that our y component is E1y plus E2y, and our E1y was given to be 131,976.4. Our E2y is given to be 197,965. So the summation of this using our calculator is going to be 329,941.4 Newton per coulomb. So we've gotten both our x component and y component of the electric field. So then let us resolve it. To resolve this, we have to draw another diagram, another right angle triangle. Why are we using a right angle triangle? That's because we've already gotten our x and y component for both E1 and E2. So our x component, our y component is here, and our x component is here. Remember, for Pythagoras theorem and the third law of vectors, it states that when two vectors are perpendicular to each other, just as y and x are perpendicular to each other here, then the resultant is gotten by using Pythagoras theorem. That is c squared equals a squared plus b squared. So automatically our E net is going to be gotten by root of our E1. No, that's not going to be 1 anymore. Okay, it's going to be EX instead. AX squared plus our EY squared. EX squared plus our EY squared. So our E net equals root of minus 28 800 squared plus 329,941.4 squared. So the final answer to our E net using our calculator is going to be okay 3.3 times 10 raised to power 5 Newton per coulombs. So that's that about this question. And in our next tutorial, we're going to be talking about Gauss law and its relationship with electric force, electric field, and electrostatics. Thanks for watching.